There's a video of mine on YouTube that has been I've only had a YouTube channel up for about 3.5, 4 months now. And I was surprised to find which videos were the most popular. And it turns out the most popular video on my YouTube channel to date, by far now, at first it didn't start out that way, but by far now is the one on water filters. I have a video on there that about basically is titled, I think I have it titled, "Don't Use Ceramic Filters for Surface Water." And that comes with a very stern warning, and this is something we're going to cover again now in more detail because a lot of people are concerned and there's misconceptions all over the place, mostly due to water filter manufacturers about these products and what their products claim to do, which they can't and don't do, but unfortunately that's what the water filter manufacturers do. For survival purposes, I would never, and I've said this on the video before, and a lot of people don't want to agree with this. Because they paid 300 and some bucks for their Berkey or whatever. They just want to shoot the messenger and call you a fool because their Berkey says they'll do any water. Well, bull crap. They will not do any water. They can't, never will, never can. I'm going to prove it to you tonight. But most of these, you have to be extremely wary of any of these water filter manufacturers that claim what they are claiming to do, because frankly, most all of them I've seen so far are lying. They're lying, okay? There's no other simpler way to put it. So if you're going to depend on something like the Berkey or the Aquarain or the ProPur or a LifeStraw or Aquasana or any of these other brands that are water filters, you are rolling the dice. You are rolling the dice. I would only recommend all of those products I just mentioned. And full disclosure here, I sell the Aquarain. It's a ceramic filter cartridge. It still will not work for surface water to make it safe to drink. Neither will any of the other brands I've already mentioned. Neither will any brand on the market that's a water filter, period. And I know you're all screaming up and down, jumping, well, my company says it will do this and that and this, and I've got some papers that says it will, and it's a lie. Look here, folks. We're going to get into this now, and we're going to go over this little by little to make sure you understand what we're talking about here, because we're talking about most of these brands that are out there on the market are some type of filter system, a ceramic filter system. Now, much of the information I'm going to give to you tonight is going to be directly from the CDC. Now, okay, for those of you who say, oh, well, it's a government agency, they're just lying to us, well, then you can go on believing that. Or you can do some more research and find out what the truth is. Just because it comes from government does not mean it's a lie. Yeah, the government lies to us about a lot of things. But this ain't one of them. Now, we're going to go over protozoa, excuse me, protozoa. We're going to go over bacteria, and we're going to go over viruses. And we're going to talk about filters. We're going to talk about UV light. We're going to talk about chlorine, iodine, boiling. We're going to talk about reverse osmosis. We're going to talk about distillation. All these methods are out there. For the intents and purposes, we're talking about survival purposes now. So if you're using any of these filters for your tap water or well water, fear not, because you won't have these things in your well water or tap water. At least you shouldn't, unless there's something extremely wrong. So we're not. If you're using these devices and you're content with your with your tap water and well water, then no worries. Okay, this is what we're talking about here now is going to apply for emergency drinking water survival purposes, where you got to go to a lake or a stream or a river or a pond or a ditch or a swamp to get the water you think you're going to be able to survive that you're going to need, and make it safe enough to drink where you don't get sick or die. That's what we're talking about here. We're talking about survival purposes for emergency water. Okay, we're not talking about well water and tap water here, because frankly, you don't need a filter for well water and tap water. Oh, you say, well, you got to filter out fluoride, or you got to filter out whatever, and we'll talk about that too if we got the time. Cryptosporidium is a protozoa. Okay, Cryptosporidium is a microscopic parasite that causes diarrheal disease. Both the parasite and the disease are commonly known as crypto. There are many species of Cryptosporidium that infect animals, some of which also infect humans. The parasite is protected by an outer shell that allows it to survive outside the body for long periods of time and makes it very tolerant to chlorine disinfection. Well, this parasite can spread in several different ways. Water, of course, is one of them, and drinking water and recreational water. is the most common way to spread the parasite. Cryptosporidium is the leading cause of waterborne disease among humans in the United States. Now, potential health effects from ingestion of water contaminated with Cryptosporidium are gastrointestinal illnesses, basically, which, for this example, for all these actually, this applies diarrhea, vomiting, and cramps. Those are the symptoms of what you could get by ingesting Cryptosporidium. Sources of all the Cryptosporidium you can get could be in the water, in drinking water, are human and animal fecal waste. So, any surface water, hear me out, any surface water could have Cryptosporidium in it. Lakes, ponds, streams, rivers, whatever, swamps, ditches, could have Cryptosporidium in it. Now, it might not, but it could have. And because anytime there's something doing its business in that water, which all lakes, streams, ponds, rivers, swamps, etc., have some animals and maybe humans doing their business in that water, Cryptosporidium could be present. So hear me out here. Now, here's the methods that may remove some or all of Cryptosporidium from drinking water. Boiling. Now, it has to be a rolling boil for at least 1 minute. And we're talking about sea levels here. If we're talking over 5,000 feet, you better boil it for 3 minutes. And boiling has a very high effectiveness in killing Cryptosporidium. Very high effectiveness. So boiling is one way. All right. Now, filtration has a high effectiveness also in removing Cryptosporidium when using an absolute less than or equal to 1 micron filter rating. Now, that's the NSF, National Science Foundation Standard 53 or 58 rated cyst reduction / removal of Cryptosporidium. So cyst reduction removal. The NSF standard 53 or 58. Now, 1 micron. As a frame of reference here, let's go back to the filters we were talking about for removing, for your emergency purposes, such as the Berkey, 0.9 microns. Their flagship black filter, 0.9 microns. Okay, so that's less than 1 micron. Okay, thumbs up, right? And then the other ones, let's say the ProPur, 0.3 microns. Okay, thumbs up, right? Aquarain, thumbs up. So that's also 0.3 microns. The Life Straw, I think, is a 0.3 or 0.2 micron. So thumbs up for that too, right? So it sounds like on the surface then, for Cryptosporidium, the water filters might do the job. We're going to pick on those particular brands because those are some of the most common out there. People are thinking they're going to use for survival purposes. Again, full disclosure, I sell the Aquarains. But I'm treating them they're all basically the same. They're all ceramic filters. I'm treating them as equals here for the purposes of this program, for emergency purposes. Other methods that may remove some or all of Cryptosporidium from drinking water are disinfection, which doesn't necessarily remove it, but it kills it. Disinfection with iodine or chlorine now is not effective in killing Cryptosporidium. Again, iodine and chlorine, which is for some, not for Cryptosporidium. Now, disinfection with chlorine dioxide has a low to moderate effectiveness in killing Cryptosporidium. So low for the chlorine dioxide. Now, the combination of filtration and disinfection has a very high effectiveness in removing and killing Cryptosporidium when used with chlorine dioxide and an absolute less than or equal to 1 micron filter rating. So if you do both the filtration and the chlorine dioxide, then you'll have a very high effectiveness. So in other words, filtering alone has a high effectiveness, but also the chlorine dioxide alone has a low to moderate effectiveness in killing Cryptosporidium. But the bottom line there is what you really need to do is you need to boil it for at least 1 minute at sea level, about 3 minutes at 5,000 plus feet. Okay, we're talking about this show, we're trying to keep people from getting sick from drinking the water that they may have to rely on when something really bad happens and there's no water available. You can't run to the store to get some bottled water. Let's see if there's anything else I want to talk about Cryptosporidium. Many, but not all, available home water filters remove Cryptosporidium. Some filter designs are more suitable for removal of Cryptosporidium than others. Filters that have words reverse osmosis on the label protect against Cryptosporidium. Okay, so reverse osmosis is not technically a filter. It's a membrane. It's a completely different type of system, but they're saying here the CDC says that reverse osmosis will protect against Cryptosporidium if it's working properly. Some of the other types of filters that function by microstraining also could work. Look at a filter with a pore size of 1 micron or less. These will remove microbes 1 micron or greater in diameter. There are two types of these filters. You have an absolute 1 micron filter and a nominal 1 micron filter. Filters, but not all filters are supposed to remove objects 1 micron or larger from water are the same. The absolute 1 micron filter will consistently remove Cryptosporidium than a nominal filter. Some nominal 1 micron filters will allow 20 to 30% of 1 micron particles, like Cryptosporidium, to pass through. Now, filter manufacturers may have to pay to have their filters tested to see if they remove Cryptosporidium or Giardia. And I guess I won't get into that part there. We won't have the time to get into all the details about every single one of these, so I'm going to have to move on. So, boiling water is the effective way, hands down, for Cryptosporidium. For the protozoa called Cryptosporidium. Moving on to protozoa, another protozoa, Giardia, also known as Giardia lamblia. Potential health effects from ingesting water contaminated with Giardia are the same thing, basically, gastrointestinal illnesses such as diarrhea, vomiting, and cramps. The sources are the same also as Cryptosporidium, human and fecal waste. Human and animal fecal waste, I'm sorry. So anytime there's something doing its business in the water, you could have Giardia present. And that means any surface water. Even your swimming pool, that means it could be, because you could have a bird flying overhead, or you could have an animal doing its business in your swimming pool. So don't think your swimming pool is absolutely immune. Yeah, your swimming pool is treated with chlorine and some other things, and already we found that chlorine is not effective against, is very low effectiveness against Cryptosporidium. The methods that may remove some or all of Giardia from drinking water are, again, boiling for 1 minute. Rolling boil for at least 1 minute has a very high effectiveness in killing Giardia. Filtration has a high effectiveness also in removing Giardia when using an absolute less than equal to 1 micron filter rating. Same thing as before with the Cryptosporidium, a National Sanitation Foundation standard of 53 or 58, listed for cyst reduction or removal. Disinfection with iodine or chlorine has a low to moderate effectiveness in killing Giardia. So you can't rely on iodine or chlorine for killing Giardia. Now, disinfection again with chlorine dioxide, though, has a high effectiveness in killing Giardia. Now, the combination, again, of filtration and disinfection has a very high effectiveness if you're using a 1 micron rating filter or less, and you're using chlorine dioxide with it. So, for Giardia, basically the same rules apply. Moving on to bacteria. The bacteria we're going to be talking about here would be E. coli, Salmonella, Shigella. I'm probably not pronouncing some of these words right here, folks. The other one would be called Campylobacter. Okay, again, I probably murdered that pronunciation, but we're talking about bacteria now. Potential health effects from ingesting water contaminated with bacteria are the same thing as before, gastrointestinal illnesses, which would probably include diarrhea, vomiting, and cramps. And again, as all the others we've mentioned so far, the sources of bacteria in drinking water would be human and animal fecal waste. Again, surface water. You won't have, unless there's something very wrong, you won't have human or fecal waste, or human or animal fecal waste in well water or tap water. So again, we're not talking about well water or tap water here. Now here's the methods that can remove bacteria from drinking water. And here we go again. Boiling has a very high effectiveness in killing bacteria. So rolling boil for at least 1 minute sea level, or 3 minutes at 5,000 plus feet altitude, has a very high effectiveness in killing bacteria. Now, filtration has a moderate effectiveness in removing bacteria when using an absolute less than or equal to 0.3 micron filter. Okay, the last two, I think we were talking with Giardia and Cryptosporidium, we were talking about 1 micron. Now we're talking about 0.3 micron filter. Okay, what is the Berkey? The Berkey is a 0.9. Oops. Even the Aquarain and the ProPur and the drinking, the straw, all the straws on the market, what they call it, the life straw, those are going to be around 0.3 microns. So those filters that go down to 0.3 has a moderate effectiveness in removing bacteria. Moderate. Doesn't remove it all. Okay? Now, disinfection with iodine or chlorine has a high effectiveness in killing bacteria. So we're not filtering there, we're killing it with iodine or chlorine. That has a high effectiveness, unlike the Cryptosporidium and Giardia. Disinfection with chlorine dioxide has a high effectiveness also. So far the chlorine dioxide has a better chance of doing the job that you need to do for already bacteria, Cryptosporidium, and Giardia. So for 3 things already. Of course, there's many types of bacteria. Now, the combination of filtration and disinfection has a very high effectiveness in removing, killing bacteria when used with iodine, chlorine, or chlorine dioxide, and a filter with an absolute less than 0.3 micron filter rating. Okay, so bacteria a little bit easier now. You can boil it, as all the 3 others. So far, boiling is the only thing that has a very high effectiveness on all counts. But a combination of filtration and disinfection with chlorine dioxide also is effective. Now we move on to viruses, and this is the one that apparently caused the most controversy on the program I did on YouTube, where I talk about do not use surface water, do not use ceramic filters for surface water. I got a lot of flack on that because people believe, because they spent hundreds of dollars on their filter, they believe that their filter will do anything because the manufacturer told them so, don't you know? Well, viruses. For viruses, we're talking about hepatitis A, norovirus, rotavirus, and enterovirus. Now, the potential health effects from ingesting a water contaminated with viruses are, again, gastrointestinal illnesses, hepatitis, and meningitis. Okay, and as far as gastrointestinal illnesses, just like all the ones we did before, that would be diarrhea, vomiting, and cramps. But besides gastrointestinal illnesses, we're also talking about hepatitis and meningitis. Sources of viruses in drinking water are, as we've talked about all night here, human and animal fecal waste. That means surface water. Okay? Even your swimming pool, surface water, swamps, lakes, ponds, streams, rivers, creeks. Anytime there's an animal doing its business in your water supply, you could have viruses. Now, that being said, viruses are rather rare in drinking water. Okay, that's a little bit of backing up here. And the colder the water, typically the less likely it will have viruses in it. Now, your springs, we haven't talked about springs any, springs are touch and go. Some springs are fine, some aren't. You don't really know where that spring water is coming from. It might have been above ground just a few minutes ago, and then all of a sudden it's coming out of the ground as a spring. So you don't know, all right? But usually spring waters are pretty good, but that again, you're rolling the dice. You have to really consider spring water to be surface water until you can prove it otherwise. So you have to be very careful with springs. Now, the methods to remove some or all viruses from drinking water is, and the bottom line is, and that's what I said on my last video, you can't remove them, period. I don't care who you think you are, and how mad you get at me, you can't remove a virus, but you can boil it, and that has a very high effectiveness in killing viruses. Aha, you see there? Boiling, but that's not removing it. It just kills it. So boiling the water for at least 1 minute, again, at sea level, or 3 minutes or more at 5,000 feet or more of elevation, has a very high effectiveness in killing viruses. Now here's the key point from this next one here, and that's why I said over and over again in my last video, filtration is not effective in removing viruses. Slap you back and forth across the face a couple times. Listen to that. Filtration is not effective in removing viruses. That comes from the CDC website. I didn't make that up. So to think your Aquarain or your Berkey or your ProPur or your Aquasana or all the other brands out there to think you're going to remove a virus with their filter, you are absolutely wrong. Absolutely wrong. Make all the negative comments you want. You are absolutely wrong, period. Disinfection with iodine or chlorine has a high effectiveness in killing viruses. So, where iodine and chlorine were not that effective in previous methods, they are for killing viruses. That's why swimming pool water can actually be a fairly good water source for emergency water. If you get stuck with a Berkey or a Proper or an Aquarine or other ceramic filter or any filtration system, you heard what I've said. If you get stuck with them in an emergency situation, your pool could be a fairly good source of water, because the chlorine in that pool, if you're using chlorine, has a high effectiveness of killing viruses. But of course, was the contact time enough? In other words, something just did something in your pool, and you go in there and grab the water and throw it in your Berkey. Well, how long was it exposed to the viruses? Has it actually been killed yet? So it's not a catch. It's not a safest method, but swimming pool water is usually a fairly good, because of that reason, because of the chlorine already in it. But back to now, the disinfection again with chlorine dioxide also has a high effectiveness in killing viruses. Now, disinfection has a high effectiveness in killing viruses when used with iodine, chlorine, and chlorine dioxide. So viruses, although they can't be filtered out, okay, what your manufacturer says, since viruses can't be filtered out, you can disinfect the water or kill the viruses by boiling. And so the ideal methods here for viruses are boiling, disinfection with iodine or chlorine dioxide for viruses. Now, of all those categories we just went through, because we're not going to go through any more categories at this moment, all those three categories we went through, you'll notice boiling was there for all of them. A rolling boil for 1 minute, or using 3 minutes or more when you're at, at least 3 minutes when you're at 5,000 feet elevation or more. So boiling is pretty much the surefire method of dealing with all these. Now, it won't filter your water. Boiling won't remove the fluoride. Boiling won't take out your iron or salt out of your water or anything like that. But it will kill the nasties that are going to make you sick. Okay, and we also seen that chlorine dioxide is very good also in all of these methods as a disinfectant. But filtration is not. So I hate to burst your bubble, but all you people that are buying these Berkeys and Aquarines and Propers and blah, 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 all these other brands that are filters for survival purposes, you're absolutely deluding yourself. These things really do not belong in a survival type situation. Here's other reasons why these types of things are not going to be good in a survival situation. Such filters having a very fine pore sieve size, if you will. In other words, they're filtering down to 1 micron or less, or 0.3 microns even. Those will, if you went out to your creek out back and you poured in a gallon of water into your system, those filters are going to plug up very quickly. If you just take it out of your creek. Now, if you filter it, pre-filter through something, there's things you can get in the stores that are lesser of a filter that'll filter out the sands and the bigger particles, okay? Then that'll help your system filter out the water without plugging up. But these very fine micron filter rating filters will plug up very quickly when you're putting surface water in them. Now, the Aquarine as an example, go back and look at that other video where I talked about, because I demonstrated in the video. You take that when they start plugging up, because the larger particles will just collect on the outside of the filters. And when all those fine little pores are starting to plug up, your filter will get less and less flow through it till it won't even flow anymore. So you have to take the filter out at that point. You have to scrub them down or replace them, and then use them again, put them back in if you're scrubbing them down. Because what you're doing when you're scrubbing them down is you're actually wearing off some of the ceramic along with the crap that's plugging up the filter. But the point being, and Berkey is one of them, is very, very bad at this with their advertising, is, oh, you can filter any water for 1.8 cents a gallon or whatever they claim. Well, what kind of water are you filtering? Are you filtering creek water or ditch water in it? No, you're not. But you say you can put any water in it, but it's going to plug up a lot quicker, and any filter manufacturer says you're going to get X number of gallons out of their ceramic filter are absolutely lying to you as well. Unless you're running distilled water through it or something like that, there's no way they can possibly know how much water that filter will take before it plugs up and has to be scrubbed down. And the more you have to scrub it down, the quicker it's going to wear out. Hence, you don't know how many gallons of water is going to go through that filter. So anybody that asks me that question when they're coming to ask questions about my filters, I tell them no manufacturer can actually know how much water their filter is going to filter before you have to change the cartridges. Period. And because of that reason, no filter manufacturer is going to be able to tell you that it's going to only cost 1.8 cents to filter out a gallon of water through our system, because it's dependent on how long the filter lasts. I'm bursting a lot of bubbles here, but it needs to be done, because for survival purposes, water is the #1 thing you're going to need. Water is absolutely the #1 thing you're going to need, besides potentially, depending on what weather you have. If it's the middle of January and it's 0 degrees out, well, you're going to need shelter before you need water, because you're going to die quicker from that. But if you're drinking bad water, that's going to be the #1 way that a lot of people are going to succumb to disease and die, is because of drinking bad water, bad sanitation. Now, we're going to do some review here. We're going to go through some things here. Remember, boiling can be used as a pathogen reduction method that should kill all pathogens. Water should be brought to a rolling boil for 1 minute. Altitudes greater than, so here they're saying 6,500 feet, greater than 2,000 meters. You should boil the water for 3 minutes. Now, filtration can be used as a pathogen reduction method against most microorganisms, depending on the pore size of the filter, the amount of the contaminant, the particle size of the contaminant, and charge of the contaminant particle. Manufacturer's instructions must be followed. Only filters that contain a chemical disinfectant matrix will be effective against some viruses. And that would be including, by the way, the aqua pale, which is a completely different type of system, even though that's only a 5 micron rating. I didn't say 0.5, I said 5 micron rating. It kills the virus with a different method, okay? And again, full disclosure, I sell the aqua pales too. Again, this is more about information than it is about sales pitches here, because I never turn my discussions into sales pitches. Now, disinfection can be used as a pathogen reduction method against microorganisms. However, contact time, disinfectant concentration, water temperature, water turbidity, meaning the cloudiness, the water pH, and many other factors can impact the effectiveness of chemical disinfection. The length of time and concentration of disinfectant varies by manufacturer, and effectiveness of pathogen reduction depends on the product. Depending on these factors, 100% effectiveness may not be achieved. Manufacturer's instructions must be followed. So if you have some of these chlorine dioxide or the iodine products or chlorine products, follow the instructions very carefully. And as an example, just like I said with the swimming pool before, that animal might have just did something in your pool and the disinfectant might not have had time to work. So with all of these products, you have a certain amount, a certain concentration. Again, follow the directions. So many tablets per gallon or whatever. And then a certain amount of time. If it says 1 hour, you need to wait 1 hour. Otherwise, you may not have killed those viruses or whatever you're trying to kill. So be very careful about following the manufacturer's instructions when you're using one of these types of products. Other methods that can be effective, I hear this all the time about ultraviolet light. Okay, here's the scoop on ultraviolet light. Ultraviolet light can be used as a pathogen reduction method against some microorganisms. Remember, look, this is what I said there. Reduction and some microorganisms. The technology requires effective pre-filtering due to its dependence on low water turbidity, I mean the cloudiness. In other words, you're using light here, so if your water is very muddy or something, the UV light may not penetrate as well, so you need to have the water fairly clear for this to work. It also has to have the correct power delivery and the correct contact times to achieve maximum pathogen reduction. UV might be an effective method in pathogen reduction in backwater country water. There is a lack of independent testing data available on specific systems. Manufacturer's instructions must be followed. So UV light might be effective is the bottom line there. Might be effective. But we don't really have the absolute proof of that. So we have to be very careful with UV light. Manufacturers that make those claims. Again, most of this information is coming straight from the CDC. Now, MIOX systems, that's spelled M-I-O-X, it's a registered system, uses a salt solution to create mixed oxidants, primarily chlorine. But chlorine has a low to moderate effectiveness in killing Giardia and a high effectiveness in killing bacteria and viruses, so manufacturer's instructions must be followed. Now, water that has been disinfected with iodine is not recommended for pregnant women, people with thyroid problems, or those with known hypersensitivity to iodine, or continuous use for more than a few weeks at a time. A few words about sanitation. In addition to using the appropriate drinking water treatments listed above, you can also protect yourself and others from waterborne illnesses in the backcountry or while traveling by paying attention to good sanitation practices such as burying human waste 8 inches deep and at least 200 feet away from natural water sources, practicing good personal hygiene, meaning washing hands before handling food, eating, or after using the toilet. Those kind of go without saying, but it needs to be said because sanitation, as I talked about this program before, when you're talking about let's say an EMP that takes the grid down and then people are dying, and what will happen is about 90% of us will be dead after a year, according to a government study, with the grid being down. And the reason for that is sanitation. Poor drinking water, no sanitation, no trash pickup, no refrigeration, no sewage removal. That's how people are going to be dying. Sanitation. And number one on that list would be drinking water. So it's extremely important about drinking water. Extremely important. Now we're going to talk about also, we had some callers on the line. Anybody want to add anything to this before I continue on? Okay, nobody wants to mute themselves and say anything, so we'll continue on. Very important program tonight. Again, if you're listening live, you're listening on May 20th of 2015. The website is forbiddenknowledge.info. I also sell water filters at the prepperstop.com, theprepperstop.com. But I'm not turning this into a commercial here. We're just talking about water here. Now, I also have a big beef with the Berkey and other brands that have these post-fluoride filters. And if you've never investigated, and I've never really talked about this on the air, but we're going to talk about it now, because I'm just getting sick of these companies that make all these claims that they're gonna just make your water just wonderful. Oh, it'll protect against chemtrails. It'll protect against whatever they're trying to scare you with. You got to research to find out if it's really going to do it, because there's all kinds of claims. I wish these manufacturers would be sued for all the claims they're making, all the bogus claims. Somebody needs to do it. Now we're going to talk about fluoride and arsenic here, because I get so many people coming and wanting to know if I have a filter that filters out fluoride. And arsenic, both fluoride and arsenic are both, fluoride has a lengthy answer on removal here, but we're going to have to go over this some. Heavy metals, arsenic, we'll have to just stress the fluoride here, and maybe a little bit of the arsenic. I'll wade through the information, probably not put you in overload here. Now, fluoride occurs naturally in some waters, as does arsenic, but is frequently added to municipal water supplies because of a widely held belief that it prevents dental cavities. And I say that loosely because it's just a belief. Look at that word belief. There might be a lie in the middle of what you believe. Think about that, folks. But they add it to water supplies because it's going to make your teeth better, don't you know? Now, fluoride is more difficult to remove than most water contaminants, so most purification brands avoid even mentioning it. Standard purification methods, such as granular activated carbon and carbon blocks, will not remove fluoride, but can marginally reduce it. This includes brands such as the Pure, the Brita, the Aquasana, etc., the types of filters that are on the market, the carbon blocks or granulated activated carbon. For practical purposes, there are 3 choices for removing fluoride from drinking water. One would be Distillation, one would be reverse osmosis. And now both of those, by the way, remove all beneficial trace minerals. And filtration through a special fluoride or arsenic reduction medium called activated alumina, or in case of the Berkey brand, for instance, called the post-fluoride filter. Now, let me pause there for a moment. We do have a little bit of time and talk about distillation and reverse osmosis. Now, neither one of those are filters per se, but they are a safe way to make the water safe to drink. Now, distillation, well, you're familiar with, basically you're boiling the water and you're collecting the steam to I want to say rehydrate, to condense it back into water, this pure water. So distillation would be, in all the methods we described this program already, about boiling. Okay, the same rules would apply for distillation. With distillation, you're also removing a lot of other things too that you may want to have removed. So distillation, although it is energy intensive, and hence may or may not be suitable for survival purposes, it is a method. Rolling boil for a minute also takes a lot of energy. Are you able to start a fire? Are you able to plug in that distiller or whatever? In other words, it's going to require a lot of energy, either distillation or rolling boil. Also, let's talk a little bit about reverse osmosis. Reverse osmosis is not a filter per se, it's a membrane, a very fine filter, not filter, but membrane. Excuse me. Reverse osmosis wastes a lot of water because you have to continually flush that membrane from any little particle that gets on it because it will plug up extremely fast. Also, reverse osmosis uses energy because it has to be under pressure. So you're either using city water pressure or else you have to use some kind of pump to keep it under pressure. It is also probably not very, well, it is effective for emergency drinking water use, but it's not very practical because you do need pressure and you do need a lot of water to flush the system. And if you're trying to use water from a lake, stream, pond, river, whatever, it's going to be very difficult to use a reverse osmosis system. So for these purposes here, although distillation will do the job and so will reverse osmosis, neither one of them may be suitable for survival purposes. Unless you do have a lot of fuel and you actually can start a fire without drawing attention to yourself, that smoke or whatever. All right? Now, steam distillers remove a high percentage of fluoride, and virtually any good reverse osmosis unit will provide fluoride reduction of 95% or better. The third method, activated alumina, called AAL, removes fluoride well, but requires a relatively large bed and very slow flow rates. Activated alumina is the most commonly used fluoride removal media today. This media is essentially a granulated or powdered aluminum oxide, that is preconditioned with chemicals. It is generally quite effective at removing fluoride, but is a toxic compound in its own right. In fact, if you are considering any filter system with activated alumina, be sure the system has KDF media downstream of the activated alumina. This will offer some level of protection when alumina makes its way into your water, as it will. You can expect a greater than 90% removal of fluoride with activated alumina. So let's review what we just said now. These media that has, like, say, the post-fluoride filters, will have aluminum in it, powdered aluminum or aluminum oxide. Now, aluminum has been linked to some brain ailments, such as Alzheimer's and some other things. You're getting the fluoride out, but you're trading it with something else that might be just as bad or worse than the fluoride. This is some hard facts that you people need to be slapped around with because you're believing the claims of these manufacturers of what their products do. Will it remove fluoride? Well, yes, it probably will, probably greater than 90%. But it might be doing some other things in your water which you may not like. And this, we just reviewed that it has to be, they have to have some other media downstream of the filter, otherwise you're going to get the alumina in your water. And what do they call those? Post-fluoride filters? These actually, if you haven't seen them, they hang up under, they go through the main filters, then they go under the system, they're actually sitting in the water, and they go through this other filter, post main filter. All right. Now, although activated carbon is not normally recommended for fluoride reduction, it is known that under the right conditions, carbon does remove some fluoride from tap water. The type that would be better, activated carbon, high quality activated coconut shell would be better at removing the fluoride. Even if fluoride removal is minimal, carbon filtration makes significant other improvements by removing chlorine, chloramines, and the byproducts of chlorination and chemicals in general. So we're not saying don't use a carbon filter, but if you're using it strictly for fluoride, it's not going to be very effective. Now we're going to skip over arsenic, but the arsenic part is also suitable with these types of filters. In other words, removing arsenic has very similar methods of removal that we're talking about here for the fluoride. There are basically two varieties or species of arsenic in water. One is arsenic 3 and one is arsenic 5. Because arsenic 3 is very difficult to remove from water, it must be changed or oxidized to arsenic 5 before it can be removed. Do some research on that. We're going to skip over pretty much the anion exchange as far as arsenic is concerned. Now, reverse osmosis is generally installed as a point-of-use treatment system and usually requires pre-filtration to remove sand and grit that might foul the reverse osmosis membrane. Reverse osmosis is considered effective at removing arsenic 3, by the way. Now, adsorptive filter media are used in both point-of-use and whole-house treatment systems. There are several varieties of adsorptive media available, including activated alumina and other types of media, including some with proprietary ingredients. Activated alumina and most other absorptive media will either not remove arsenic 3 or are not very efficient at removal of arsenic 3. The efficiency of removal is dependent on the pH of the water and may require pre-treatment to adjust the pH. There is a ongoing cost replacement of absorptive media of cartridges. The media can be disposed of as a non-hazardous waste. Let's see, I'm going to skip over some of this other stuff because it's more getting into advertising for a particular brand, which I won't get into here. Activated alumina has a very high surface area to weight ratio with a lot of tunnel-like pores that run through it. For fluoride removal, you need a lot of surface area against which the water interacts. Through the attraction of metals, the fluoride can be removed. Over the time the surface alumina gets coated with a cartridge, it needs to be replaced. Size of the, need to move this here. For fluoride reduction now, do not discount the danger of fluoride and arsenic reduction or removal. There are great strengths to be found in different systems, especially for bacteria, cysts, protozoan removal, VOC contaminants, chlorine, benzene. Some pharmaceutical drug removal can be accomplished with some types of systems, and a lot of these systems, by the way, the pharmaceutical drug, the trace pharmaceuticals, is about the most difficult thing the water industry is having to deal with right now as far as water treatment systems. Let me talk about seawater a little bit, because we haven't talked about seawater, because some of you may have to think you have to rely on seawater. Well, seawater can be made safe to drink. Essentially, my understanding, if I don't have the information directly in front of me, about the only things you really can do for seawater would be distillation and reverse osmosis. Those two methods, which again we said probably were not very practical for survival purposes, were nonetheless very effective. If you had the power to use them, then yes, reverse osmosis and distillation would be good for virtually everything, including seawater. So seawater poses a special challenge because the salt is in solution. Some filters will remove the nasties in it, but the water will still be salty. Now you can drink a little bit of salty water for a shorter period of time. You can't do it for very long because it will tend to dehydrate you rather than hydrate you. So it's okay to drink some salt water for short periods. In fact, it can in fact be a little beneficial. You know, if you ever researched that on salt, you might be very surprised what you find. But you can't survive on just seawater alone, even if you remove all the nasties in it that will make you sick. All right. So seawater poses a special problem.